Today we are evaluating piecewise functions. So I am given this function, f of x, and I'm going to use this top equation if x is less than -2, and I'm going to use this bottom equation if x is greater than or equal to -2. So we're going to find each of these values. So here I'm going to plug in -5 into this x right here. So I want f of -5. Now, -5 is less than -2. -5 is not greater than or equal to -2. So I'm not going to use this bottom equation for f of -5. I'm going to use the top equation. So I'm going to plug that into my function, plug in a -5. -5 squared is 25, minus 1 is 24. So f of -5 is equal to 24. Next, we have -2. So let's see which equation I should use. So -2 is not less than -2, so we can't use that one, but -2 is greater than or equal to -2. So I'm going to use this bottom equation, and I'm going to plug in my -2. 5 times -2 is -10, plus 3 is -7. And you can do the last one on your own. We're going to continue evaluating piecewise functions. This time I have 3, but the steps are the same. So this one, we're going to evaluate this function at 2. And this says G. I'll change that back to an F so that they match. Okay, so we're going to plug in a 2. 2 is not less than or equal to -4, so I can't use that one. 2 is greater than -4, but it's not less than 1. So 2 is not between -4 and 1, so we can't use that one. 2 is greater than or equal to 1, so I'm going to use this bottom equation. Okay, so I'm going to write my function. I'm going to plug in a 2. 2 cubed is 8. 2 times 2 is 4, times another 2 is 8. Now we're going to multiply by 2, which is 16, plus 9 is 25. Notice I did the exponent first because you need to remember the order of operations. We have exponents before we do multiplication, and then addition will come last. Okay, next we're going to plug in a -1. So let's figure out which equation we're going to use. -1 is not less than or equal to -4. That's not true. -1 is between -4 and 1, so I'm going to use this one. And -1 is not greater than or equal to 1, so that one didn't work either. This is the only one that works. So I'm going to write down my function. And instead of x, I'm going to substitute -1. Well, 2 negatives make it positive, and 1 minus 1 is 0. And you guys can do the last one on your own. So now that you know how to evaluate a piecewise function, now we're going to practice graphing. So we're going to graph this system or this piecewise function. So you can imagine if f of x, if you don't like writing f of x, you can just think of this as y. Y equals x. That's your first equation. So I'm going to go ahead and graph it. We already know how to do this. You're at the origin and your slope is 1. Okay, so this is my line, y equals x. However, it only wants this line for x values that are less than or equal to -5. So this is the x-axis, and -5 is right here. I only want x values that are less than -5, okay? So that means I'm going to get rid of all of these because all of these x values are bigger than -5, right? The x value here is -4. This x value is -3. This one's -2. This one over here is about like 6. All these numbers are bigger than negative 5. I want less than or equal to. So I'm going to get rid of this side. I don't need these. Okay, I don't need those points. So I'm going to do a closed circle because there's an equal sign at negative 5. So this is the x value negative 5. It's going to be a closed circle, and that is your line. So what I have here is the line y equals x, and I only have it for the x values that are less than or equal to negative 5. This has an equal sign, so I have a closed circle at negative 5. Okay, let's try the next one. This one is y equals negative 2x plus 1. This is your y-intercept. Your slope is negative 2, so you're going to go down 1 over 2. And this direction. Okay, so that is our line. Now, we only want the part of the line for x values that are greater than negative 3. Negative 3 is right here. I want the part of the line that's greater than negative 3. So that means these I'm going to erase. So let me erase this part. I only want x values greater than negative 3. So that's that side. Okay, now notice this does not have an equal sign. So this will be an open circle at negative 3. So this is the point that's at negative 3. That needs to be an open circle. And this is your line. Okay, now let's talk about where the maximum is. We're going to find the maximum over this interval, negative 2 to 2. So if I were to put some lines from negative 2 to 2, this is what you're looking at. This is the interval that you're paying attention to. The maximum point on this interval, negative 2 to 2, is right here. And that is the y value, 1, 2, 3, 4, 5. So that means the maximum is 5 on this interval. Now the minimum over this same interval, the lowest point between here and here, is right here at negative 3. So the minimum is negative 3. Now let's talk about domain and range. Okay, so your domain. Your domain, you always read it from the left to the right. So here's the left side of the graph, and it's pointing to the left. So that's negative infinity. And you're going to follow the line, and it stops right here at negative 5. Since that is a closed circle, I will use a bracket. Then it continues right here at negative 3. So I'm going to put and negative 3. That's an open circle, so that'll be a parenthesis. And then it keeps going to the right. So that is infinity. That is your domain. Domain represents all of the possible x values. Notice there's no points between negative 5 and negative 3. There's no points that exist. So that's just that open space there. So this part represents the x values here. Negative 3 to infinity represent these x values. Okay, now let's talk about the range. This is pointing down, so it's going from negative infinity, you start at the bottom, and then you go up. So if you follow this line, it goes all the way up to 1, 2, 3, 4, 5, 6, 7. And that's an open circle, so it will be a parenthesis, okay? Now remember, the definition of range is all of the possible y values. If you're curious about this one, well, the range of this one would be negative infinity. That's what's at the bottom. And then it goes up to 1, 2, 3, 4, 5, negative 5. Well, guys, that is included in this interval. Okay? 5 is right here on this line, and we already included it. So you don't have to do it twice. You don't have to do that twice. Okay? Our next example. We're going to graph, you can change this to y, this line y equals negative 3x minus 7. Your y-intercept is at negative 7. So put a point on the y-axis at negative 7, and your slope is negative 3. So I'm going to go down 3 over 1 to create a negative line. You can also go this direction. Okay, so this is my line. However, I only want x values that are less than negative 1. So here is the x-axis, and this is negative 1 on the x-axis. The values that are less than negative 1 are on this side. That means I need to get rid of the things that are on this side of negative 1. So I'm going to erase those points. I don't need those. So let me get rid of those points. Now I have the values that are less than negative 1. Now notice this is just the less than symbol. So you need to have an open circle at negative 1. So I need to change this point to being open right here. And this is your line, okay? So notice I have all values that are less than negative 1 represented in my line. So that was your first equation. Now let's graph the second equation. This is y equals negative 5, okay? That is just going to be a horizontal line. So I'm going to go to the y-axis at negative 5. And that is your line right here. Okay, now I only want this line for x values that are greater than or equal to negative 1. So again, this is negative 1 right here. I only want this side, the right-hand side of negative 1, because those are the values that are bigger than negative 1. So I'm going to redraw this line, and I just want the values to the right of negative 1, because this is greater than or equal to negative 1. Because you have the equal sign, this will be a closed circle at negative 1, and that's what I have right there, a closed circle at negative 1. So this is your piecewise graph. Now, let's talk about the maximum. I'm given the interval negative 3 to 4. So that's the window that I'm going to look at, from negative 3 to 4. This is the part of the graph that I'm paying attention to, just between negative 3 and 4. The highest point of my graph between here is right here. That's the y value 2. So the maximum on this given interval is at 2. Now on the same interval, the minimum is down here at negative 5. So the minimum is negative 5. Okay, now let's talk about the domain. Domain, you always start on the left. Let me get rid of these intervals. Okay, so you always start on the left for domain. So it's going to continue to go to the left. Those x values are continuing to go to the negatives on the left side. So that's negative infinity, and you need to follow the line. Okay, something is happening right here at negative 1. At negative 1, you have an open circle and a closed circle, okay? Now, just pause right here. The definition of domain is all x values. All the x values that exist in this function, okay? So negative 1, it does not exist on this line because there's a hole. However, negative 1 does exist on this line. So that means negative 1 does exist for this function. It's on our graph. It's right here. So negative 1 is not an issue. So let's continue. It just goes forever to the right. So this is all real numbers. Your domain, it encompasses everything. Negative 1 was not an issue because there's a closed circle right here, even though that one was open. Now, let me just give you another example. Let's pretend that this was not a closed circle, and let's pretend that it was also open. If this is open at -1 and this one is open at -1, that means -1 doesn't exist for either line. If it did not exist, then your domain would be this. Your domain would be -infinity up to -1. And then it would continue for this line at -1 to infinity. That's if they were both open, okay? So this part of your domain, -infinity to -1, that covers these x values all the way up until -1. It's a parenthesis because there's a hole there. You cannot equal the -1. And then this part of the line is represented right here in the domain from -1 to infinity. That's if there was no closed circle at all, okay? All right, let's move on to the range. Range, you read it from the bottom to the top. So we're gonna start at the bottom here, and this was a closed circle. So your bottom is right here, that's at -5, so I'm gonna write -5. And let's just zoom in to this part of the graph. If I were to zoom in, let me draw what it would look like. That's to this one, and this one goes like that. If you were to zoom in, that's what it looks like. Notice this is at -5. This open circle, that's at -4. That's at -4, okay? So there's a big jump. There are no x values between this space. Numbers like -4.5, -4.8, those numbers are not included in our graph. There's a jump right there. So -5 is by itself. It's just this number 5, -5 right here. Then it continues at -4. So I'm gonna put -4, and then it goes up from there. That's infinity. And you can put the union symbol. The union symbol in math basically means and. Your range is -5, and then it starts at -4 and goes up. -4 to infinity. Let's try another example. Okay, so we're going to graph this line. Your y-intercept is at 2, so put a point at 2. Your slope is -3. So you're going to go down 3 over 1, down 3 over 1. And you can also do it in this direction. Now, I only want x values that are less than 2. So 2 is right here. I want less than 2, so I'm going to get rid of these points. The x value here is 3 and the x value here is 4, okay? We don't want those. So I'm going to erase those points. Okay, and notice this does not have an equal sign, so it needs to be an open circle at this number 2. So this is the x value. This point has the x value 2. This needs to be an open circle. So now this is your line. Okay, now this one. This is the equation y equals 3. If it's just a number, it's going to be a horizontal line at 3. So I'm going to go to 3. This is the line at 3. However, I just want it when x is greater than or equal to 7. So 1, 2, 3, 4, 5, 6, 7. I just want it here and to the right. These values are bigger than 7. So I'm going to redraw this, and this is going to be a closed circle since there's an equal sign there. So I'm going to have a closed circle right here, and it's going to go this direction. Okay, so that is my piecewise function. Let's talk about the domain and the range. So domain, the left side, it's pointing to -infinity, and follow the line, it stops right here at 2. And that's an open circle, so it'll be a parenthesis. It picks back up right here at 7, and it's going to be a bracket on 7, and then it goes off the page to infinity. Now your range, the very bottom is at -3. So the bottom is at -3, and that's a parenthesis because it's an open circle. And then it just goes on forever, infinity. You can just ignore this. This is the y value 3, and that's already on this point. That's already a point on this line. There is an infinite number of points on this line. 3 is already represented when I did this, right? 3 is already in this range. So you don't have to worry about this one. It's already included. Okay, next example. We have y equals negative 3x. I wrote it big right here. So you don't have a y-intercept, so you're going to start at the origin, and your slope is negative 3. So down 3 over 1, down 3 over 1, just like this. Okay, and I only want values less than 0. So 0 is right here. I want less than 0. So I'm going to get rid of this side. I just want less than 0. There is no equal sign right here. So this needs to be an open circle. This needs to be open. And we're going this direction. There we go. So that's the first line. We just did that one. Let's do the next one. This says y equals negative 1/2 x minus 1. So your y-intercept is negative 1. So here's negative 1 right here. And your slope is negative 1/2. Down 1 over 2, down 1 over 2, and continue that line. You can also go this direction to continue the line. However, it only wants x values between 0 and 6. Between 0 and 6. So I just want it between here and here. 1, 2, 3, 4, 5, 6. Okay, so I'm going to get rid of these points that are outside of 0 and 6. Okay, and I'm going to edit this problem. Let's make this an equal to sign. Okay, so I'm going to do an open circle. This will be open at 0. And this will be closed at 6. Okay, I put a line under there. I put an equal sign. So I need it to be open at 0. So I'll do an open circle here and a closed one there. Okay, so this is my line. Okay, now the last one, we have x minus 7. So my y-intercept is negative 7. 1, 2, 3, 4, 5, 6. Negative 7 is right here. And your slope is just 1. So it looks like this. Okay, but they only want values that are greater than 6. 6 is right here. I just want the side that's greater than 6. So I'm going to erase all of these. I don't need those. I just want greater than 6. And this is going to be an open circle because there's no equal sign on the 6. So I'm going to change this circle to be open. And this is the line. Okay, so let's look at the maximum and minimum. So the interval that they gave us is negative 2 to 2. So between negative 2 and 2, the highest point is right here at 1, 2, 3, 4, 5, 6. And the minimum point is right here. That's the lowest point of this graph. And that's at negative 2. Okay, now let's do the domain and range. All right, so the domain. You always start on the left. So this is pointing at the left side. That's negative infinity. If you follow it, something happens right here. Now, since both of them are open, I'm going to put 0. So that represents this black line. Negative infinity to 0 is that part of the domain. And then I'm going to continue with this line. It goes from 0 to 6. Okay, now it starts at 0 and it gets here to 6. Because there is a closed circle at 6, you can just ignore this open circle because the x value is included right here. And then it continues going this way. So that's infinity. So because there's a closed circle here, we can just ignore the 6. It's okay. 6 is a part of the domain, so we don't need to put any special attention to it. However, because there's 2 open circles here, we could not include 0. Okay, so that is your domain. Let's talk about what ifs. What if this was actually a closed circle. If this was a closed circle, there's a closed circle here at 0, and there's a closed circle here at 6. So if it looked like this, it would just be negative infinity to infinity. Okay, that's if this was closed. But since that is open, in this example, it would be this. All right, now let's talk about the range. Your range, you start at the bottom. This bottom is at -4. So I'm going to put -4. Okay, if I follow the line, there's an open circle right here at -1. So -1, the y value -1 is not included for this line. And if I go over here, it's not included in this line either. So -1 does not exist for either of these lines. So -1 does not exist. However, after -1, it just goes up forever. Okay, it just goes up forever. So that's -1 to infinity. So -4 to -1 is the range from here to here. It's not including -1, but after -1, it goes up. So that's -1 to infinity. I do not have to worry about this open circle. This is the y value 0 because there's a y value 0 right here. This is the 0.70. So this y value is included. So we don't have to worry about 0. So that is your range. Now let's do what ifs again. What if this was a closed circle? If that was a closed circle, it would go from -4 to -1, and since it's closed, that's included. And then after -1 here, it just goes up forever. We can ignore the -1 because there's a closed circle on -1. So if your graph looks like this, your range, if this one was closed, would just be -4, and that's going to be a bracket at -4 to infinity. Did we say this one was closed? Let's see. Yes, we said this is closed. Okay. So that means if this was closed, I can't remember what I changed. If this one is closed, that means -4 has a bracket, okay? So if that's closed, -4 has a bracket. All right, so guys, that's an example. I hope that helps.